Hello, everyone, and welcome back. Today, we are going to be talking all about solving polynomial equations. We're going to be doing a few different things to solve these equations. So, I'm first going to go over what are the steps we need to take to actually solve the polynomial equation. The first step is to find a factor using factor theorem. So, step one, find a factor using factor theorem or remainder theorem, sometimes it's called as well. That's step one. Make sure to write these down, these are important. Step two is use long division to divide by the factor using long division, or short division if you prefer. Divide by the factor using long division. And then after that, we would repeat steps one and two until other factoring methods are possible. So once we've done step one and two enough times, that we're then able to stop and say, okay, we now just have a quadratic, we can factor it that way, or we now just have a quadratic and this quadratic isn't able to be factored, so we're done the whole question, something like that. That's when we would stop and move on to step four, which is fully factor the rest. And then step five would be to solve from factored form using the zero product property. Okay, so those are the five steps. So now I'm going to actually go over a full worked example with all five of these steps. So step one, let's highlight step one in purple, which is going to be finding a factor using factor theorem. So just a reminder, we talked about factor theorem next day. It is a new topic in this course. Basically, factor theorem states, let's go back and see what it states. It states that if f of a is equal to 0, then that means x minus a is a factor in the polynomial, right? Because f of a is the remainder when f of x is divided by x minus a. And so if that remainder is 0, that means we found ourselves a factor. So I then ask, what do we think something would be, what do I think I could plug into this equation in order to get a factor? Well, my instinct is telling me maybe if I find f of 1, it will be 0, right? I'm pretty sure just kind of looking at this question that might be the case. And that's always what I advise to try the most obvious things first. Think about, okay, would 1 work? Would -1 work? If not, okay, would 2 work? Would -2 work? Because in general, with these questions, some of the factors are harder to find than others. So I would just go with what's the easiest thing we can find right away. And that's not to say it'll be wrong if you find, if you search for a more difficult factor, it's just going to take you a longer time, but it will not be wrong. Okay, so f of 1 is equal to 1 cubed minus 4, 1 squared minus 7 times 1 plus 10, which is equal to 1 minus 4 minus 7 plus 10, which is equal to 0. So therefore, x minus 1 is a factor. Awesome. Okay, so now let's do step two. Step two I'll highlight in pink, and that is to do long division by this factor to find the answer, to get one step closer to our answer, basically. So let's do that. Here we have x minus 1, and then here we have x cubed minus 4x squared minus 7x plus 10. Okay, so how many times does x go into x cubed? Well, x squared times. And then what's x minus 1 times x squared? Well, let's use our rainbow rule or our distributive property for this. X times x squared is x cubed, and -1 times x squared is -x squared. And then we're going to subtract. So then we're going to get x cubed minus x cubed, which is 0. And we're going to get negative 4x squared minus negative x squared, which would be negative 3x squared. So there we go. Then we're going to bring down the minus 7x. Now, how many times does x go into negative 3x squared? Well, negative 3x times. What's x minus 1 times negative 3x? That would be negative 3x squared. And then negative 1 times negative 3x would be plus 3x. And then we're going to subtract. And over here, we're going to get negative 3x squared minus negative 3x squared, which is 0. And then over here, we're going to get negative 7x minus 3x, which is negative 10x. Then we're going to bring down our 10. How many times does x go into negative 10x? Well, that's negative 10 times. X times negative 10 is negative 10x. Negative 1 times negative 10 is plus 10. And then we are going to subtract and we get 0, and we get that the remainder is 0. And something I can't stress enough is that, let's say we didn't get remainder 0 here, but our factor theorem told us we should have. That means either when we applied our factor theorem, we applied it incorrectly or made a calculation error with our factor theorem, or the more likely thing would be we made a mistake somewhere in the long division, because if these remainders don't line up, then that is inconsistent and there is some type of a problem. Good, but either way, that is step 2. Now, step 3 says repeat steps 1 and 2 until other factoring methods are possible. Well, we can just skip. We don't have to go back to 1 and 2 in this case because already we have a quadratic, so other factoring methods are possible. So I'm going to skip that one here and move to step 4. Okay, so step 4 would be, we want to factor this further. So now we have x minus 1 times x squared minus 3x minus 10, based on that long division we just did, is equal to 0. So now we're going to factor this further. So how would we factor x squared minus 3x minus 10? Well, this is a quadratic, so we just have to find two numbers that multiply out to negative 10 and add up to negative 3. And I think maybe 5 and 2 could do that. Yeah, 5 and 2. Well, one of them's going to be negative. We got to do negative 5 and 2. Yeah. So x minus 5, x plus 2. And if we expand that out, just in our head quickly, we will see that we do end up getting the same as the above back. So there we go. So now we've done step 4, we fully factored the rest. This is now fully factored. Now I will say that just because we have a quadratic, something like this, in some cases something like this could be considered fully factored if the quadratic is not factorable. But if the quadratic is factorable, which in this case it is, this form here where we still have a quadratic on our hands is not fully factored because it is possible to factor further in this case, so we need to do that. Okay. Now step 5, let's use a different color. Let's use 5. It says to solve from the factored form. So here we just have to use our zero product property and say, well, we know that x minus 1, x minus 5, and x plus 2, that one of them has to be 0 for the whole thing that we're multiplying together to be 0. So for the solving, it's either x equals 1, x equals 5, or x equals negative 2. And so those are our solutions. We were told to solve this, and we did. We solved that that these are the 3 solutions here. And there we have it. Now we're done. Okay, let's move on to a second example. I actually think today there's going to be 4 examples for us. Let's move on to our second example here, though. So for this one, there's actually an extra step we need to do that I didn't include up here. Before we can even apply factor theorem, we need to get all of our variables and just terms in general, actually, because our constant counts here as well. We need to get all of our constants and variables and coefficients and everything onto one side, and the other side needs to just be equal to 0. So let's do that. I'm going to say that this is the same thing as 2x cubed plus 3x squared minus 11x minus 6 is equal to 0. Okay, so now let's go into step 1, and let's use factor theorem to try and figure out what is a factor here. So let me just think about it. Would 1 be a factor here? No. What about -1? I don't think so, no. What about 2? Would 2 work? 2 might work. F of 2 might work here. So let's try. So 2 times 2 cubed plus 3 times 2 squared minus 11 times 2 minus 6 is equal to, let's see, 16 plus 12 minus 22 minus 6, which that's going to be 28 minus 28, which is 0. Aha. So there we have it. X minus 2 is a factor. So since x minus 2 is a factor, we're going to write this down. X minus 2, and then 2x cubed plus 3x squared minus 11x minus 6. Okay, so how many times does x go into 2x cubed? Well, 2x squared times. What is x times 2x squared? That is going to be 2x cubed. And what is -2 times 2x squared? -4x squared. Okay, and then we are going to subtract. 7x squared is going to be our solution here. So we have 2x cubed minus 2x cubed, and then we have 3x squared minus -4x squared, which gives us 3x squared plus 4x squared, which is 7x squared. Now, how many times does x go into 7x squared? Well, 7x times, so we'll add that in. Okay, so what is x times 7x? Well, 7x squared. And what is 2 or -2 times 7x would be -14x. When I didn't bring down the -11x, I should have done that earlier. And then we're going to subtract. So we're going to end up with 7x squared minus 7x squared, which is 0. And then -11x minus -14x is going to be 3x. Then we bring down this -6. Okay, how many times does x go into 3x? Well, 3 times. So what is x times 3? Well, that's going to be 3x. What is -2 times 3? Well, that's -6. And then we get remainder 0. And again, we must get remainder 0 here, otherwise there's a problem, because according to our remainder theorem that we did earlier, we do get a 0 here. And so it's important that it stays consistent. Okay, so now we know that we have x minus 2 times 2x squared plus 7x plus 3 is equal to 0. And now we just need to factor this using other methods. So we know, or I mean, we could keep doing the long division method, but we already know easier methods for quadratic, so we're just going to do that. Okay, so now we have a quadratic on our hands, so we need to find things that multiply with 2 and 3 that give us 7. So 1 times 1 is 1, and then 2 times 3 is 6, and 1 plus 6 gives us 7. And so that's going to be our answer. We're going to end up with x minus 2 times 2x plus 1 times x plus 3, I believe, should get us there. And yes, it does. It does get us there. And so therefore our answers are what? X equals 2, x equals -1/2, and x equals to -3. And there we go. We're all done. Okay, let's do example 3. Okay, so example 3, this is an example where where there's a higher chance that we're actually going to have to do step 3, where we actually repeat some of the steps, repeat steps 1 and 2, because after factoring this by a linear equation, we're still going to end up with a degree 3 polynomial. And then so we'll likely have to use the same method again to do long division a second time, and then at that point we'll get to a degree 2 polynomial. Okay. All right. So let's go ahead and do it. All right. So in this case, what do I think we could plug in here to maybe get remainder 0. I'm just trying to think of what we could plug in. Would 1 work? I don't think 1 would work, but what about -1? Would that work? Maybe. Maybe. Let's see. Let's try f of -1 and see if that would work. We would get 2 times -1 to the power of 4 plus 5 times -1 cubed minus 5 times -1 squared minus 20 times -1 minus 12, which is 2 minus 5 plus 20 minus 12. That is 0. So excellent. So that means x plus 1 is a factor. So now that we know that it's a factor, we've got to do long division here. So let's do that. We have x plus 1 out here. And then here in our division brackets, we have all of this. There we go. Okay, first question. How many times does x plus 1 go into 2x to the power of 4? Well, let's see. That's going to be 2x cubed times. What's x times 2x cubed? That's going to be 2x to the power of 4. And what's 1 times 2x cubed? Well, that's just going to be 2x cubed. And then we're going to subtract. Okay, so we do 2x to the power of 4 minus 2x to the power of 4, which is 0. And then we have 5x cubed minus 2x cubed, which is 3x cubed. And then we bring down the negative 5x squared. Okay, how many times does x go into 3x cubed? Well, 3x squared times. X times 3x squared would be 3x cubed. And then 1 times 3x squared would be 3x squared. And then we're going to subtract. And then we get 3x cubed minus 3x cubed, which is 0. And then negative 5x squared minus 3x squared is negative 8x squared. And then we bring down the negative 20x. Okay, how many times does x go into negative 8x squared? Well, negative 8x times. Okay, very good. So x times negative 8x is negative 8x squared. And then 1 times negative 8x is negative 8x. And then we subtract. And then we're going to get 0 here. And over here we'll get negative 12x. Then we'll bring down the negative 12. How many times does x go into negative 12x? Well, negative 12 times. And then x times negative 12 is negative 12x. 1 times negative 12 is negative 12. And so we have remainder 0, which is good because we want to be consistent with that. Now, unfortunately, we're getting there, but we still have some uncertainty here. Let's actually put some space over here to actually do the question. We have, originally it was 2x to the power of 4 plus 5x cubed minus 5x squared minus 20x minus 12 equals 0. And we now have it down to x plus 1 times 2x cubed plus 3x squared minus 8x minus 12 equals 0. Okay, so now I'm going to let h of x, because we're not using f of x anymore, we're now using h of x. Let's let h of x be equal to the new function that we're trying to factor further. Okay, so what can we factor this new function by to factor even further, right? Because now we factored one linear relation out, so to speak, right? We factored x plus 1 out, but we need to repeat steps 1 and 2 again a second time in order to divide this, because in order to fully factor this, because we don't have a method for factoring this further other than the method we've already been using. Now that said, we'll just have to do it once more, because after we do this one more time, we will get something we're happy with. All right, so unfortunately, looks like 1 and -1 aren't going to work here, but 2 might work here. So let's try h of 2. That's going to be 2 times 2 cubed plus 3 times 2 squared minus 8 times 2 minus 12, which is going to be 16 plus 12 minus 16 minus 12. Oh, well, that's clearly going to be 0. So therefore, x minus 2 is a factor. Awesome. There we go. Okay. So let's do that. We have 2x cubed plus 3x squared minus 8x minus 12. And we have x minus 2 as a factor. So let's do it. Actually, I'll put this conclusion up here a little bit, because this is our conclusion from last time. Okay. All right, so how many times does x go into 2x cubed? Well, 2x squared times. X times 2x squared is 2x cubed. Negative 2 times 2x squared is negative 4x squared. And then we're going to subtract. So we have 2x cubed minus 2x cubed, which is 0. And then 3x squared minus negative 4x squared is 7x squared. Then we're going to bring down the negative 8x. So how many times does x go into 7x squared? Well, 7x times. So x times 7x is 7x squared. Negative 2 times 7x is negative 14x. Then we're going to subtract. 7x squared minus 7x squared is 0. Negative 8x minus negative 14x is really negative 8x plus 14x, which is 6x. And then we're going to bring down the negative 12. How many times does x go into 6x? Well, 6 times. X times 6 is 6x. Negative 2 times 6 is negative 12, and we get remainder 0 as expected. So there we go. So now we can do our second step here. We now have x minus 2 times 2x squared plus 7x plus 6 equals to 0 there. And now we just have a quadratic we need to factor. So the question is, can we factor this quadratic further? Well, let's see. Let's see if we can. We have the numbers 2 and 6. So that's 1 times 2, 1 times 6, and 2 times 3. And can we get those to add up to 7? And yes, we can. 2 times 2 is 4, plus 1 times 3 is 3, is going to be 7. So therefore, x plus 1, x minus 2, and then for our new ones, we're going to have 2x plus 3 and x plus 2 equals to 0. And there we go. So therefore, our solutions are x equals to minus 1, x equals to 2, x equals to negative 3 over 2, or negative 1.5, and then x equals to negative 2. And there we go. Those are our answers. Awesome. Very good. So in this case, the other cases there were 3 answers because it was degree 3. In this case, there were 4 answers because it was degree 4. So keep in mind that the maximum number of solutions we can get is the same as the degree. So for a linear function, we can only get, there's only one solution, right? Only one, only once do we have a 0. For quadratics, there's going to be 2 at maximum, right? Sometimes a quadratic might not have any solutions, right? Can't be factored at all. Or sometimes a quadratic might have one solution in a very specific case where we have where it's like a sum of squares, difference of squares. No, and we have x, the same factor twice. So x minus 3 squared, for example, something like that. We would just have the one solution. So that is possible too. And then with degree 3 polynomials, we usually have 3 solutions, but sometimes we could just have 2 or 1 solution as well. With degree 4, we could have, up to 4 solutions. So we could have 4, 3, 2, 1, or 0 solutions for degree 4. Now, when they ask you to solve these or factor them or things like that, typically they're not going to be that mean and give you something that literally just doesn't have any solutions. Because if they gave you a degree 4 polynomial that quite literally did not have any solutions at all, we would just be on step one forever, doing factor theorem, trying a bunch of numbers, not getting anywhere, not making any progress, because there would be no factors. Like there would be nothing we could do there. Um, so they, probably in practice they wouldn't actually give you one like that, even though technically it's possible to have one like that. Okay, I know this is getting kind of long, so let's do one more example and then we'll be done for the day. Here it says an open top box is made from a rectangular piece of cardboard with dimensions 15 centimeters by 20 centimeters by cutting congruent squares from each corner and folding up the sides. Determine the dimensions of the squares to be cut to create a box with volume 378 centimeters cubed. Okay, so at first glance, this might seem like a geometry question as opposed to a polynomials question, but this is actually going to be this is very much relates to everything we were just doing, to long division, to factor theorem, to all of it. So first, let's talk about what this is going to look like. So what does it say again? It says that we have a rectangular piece of cardboard, so let's draw a rectangle. And then we're going to make a box. And this has dimensions of 20 by 15. And we're going to make a box where we cut out these four corners, 1, 2, 3, 4 corners, and then fold up the sides to make like an open top box. So we have X, 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 X. And we want to know how big to cut these, to cut this, right? Determine the dimensions of the squares that we should cut on each side, basically. The dimensions of the squares that are going to create this box. Okay, so if we're going to do that, let's pretend we're now folding up our box and we now have like something like this. We're folding up our box. Well, what would the dimensions be now? Well, this first dimension here would be 20 minus 2x, right? Because we would have our 20 for the full length of the box, but we're cutting out a square on each side with a length x, so minus 2x therefore. And then we have, this one would be 15 minus 2x for the same reason. And then the other dimension, if we fold the boxes up, right, would just be x. So therefore, we know that x times 20 minus 2x times 15 minus 2x is equal to 378, right? Because we know that length times width times height is equal to volume. And they told us in the question volume was 378 centimeters cubed. And so we're good. Now, what a lot of people might do here is just say, okay, well, so the answers are 0 and then 10 and 7.5, but that's actually not quite right, because this side is not 0. This side is 378. Those would be the answers for what if our volume was 0, which, I mean, not that that would make any sense anyway, but that's essentially what we'd be going for here. Okay, and so we need to actually expand all of this and then move the 378 to the other side and then figure out how we're going to solve it. So let's do that. Unfortunately, it's a kind of tedious work, but let's do it. Let's expand these. Let's see. So 20 times 15 is 300. And then 20 times negative 2x is negative 40x. Negative 2x times 15 is negative 30x. And negative 2x times negative 2x is 4x squared. Okay. And then I'm going to put the x in there too. So we have 4x cubed minus 70x squared. And then we have let's see, so 300x, and then minus 378 from the other side is equal to 0. So this is the equation we're working with. So as you can see, we ended up with just as the same kind of question as before of solve this equation. Now we did have to do some steps in order to get there. So in order to actually get at what they're really asking for, we had to do some steps. Okay, so now let's go to, now that we have a question like this, let's go back to our original steps of how to factor and solve a polynomial. The first one is to find a factor using the factor theorem. So what number could we put in here to get 0, right, to get remainder 0? Well, let's see. 1 isn't going to work. Neither is -1. Is 2 going to work? No, I don't think, no, 2 is not big enough to work. We need something bigger. Maybe 3. I think 3 might be our winner here, but let's see. What's f of 3? That would be 4 times 3 cubed minus 70 times 3 squared plus 300 times 3 minus 378, which would be, let's see, 4 times 27. 4 times 27 would be 108 minus, let's see, 70 times 9 would be 630 plus 900 minus 378. And if we add all that up, I do think we get 0. We do get 0, yes. Awesome. So therefore, x minus 3 is a factor. Awesome. Okay. All right. 4x cubed minus 70x squared plus 300x minus 378. And then over here we have x minus 3. So there we go. Okay, so x times what is 4x cubed? 4x squared. So x times 4x squared is 4x cubed. And then -3 times 4x squared is -12x squared. And then we're going to subtract. And we have 4x cubed minus 4x cubed, which is 0. And we have -70x squared minus -12x squared, which is really -70x squared plus 12x squared, which is going to give us -58x squared. And then we're going to bring down the 300x. Okay. How many times does x go into -58x squared? Well, -58x times. That's going to be -58x squared. And then -3 times -58x is 174x. And then we're going to subtract. And we're going to end up with 126x. And then we're going to bring down our -378. Okay, so how many times does x go into 126x? Well, 126 times. There we go. So then we have 126x minus 378, which is going to give us a remainder 0, which is good. That's exactly what we want. Okay. Awesome. So therefore we factored it a little bit. We factored this down to x minus 3 times 4x squared minus 58x plus 126 is equal to 0. So ordinarily I would say, well, we're not done. We have to factor this even further. We have to factor this quadratic. But I have a question. Is this quadratic actually factorable? Well, let's see. How do we know if it is or not? Well, we know that if b squared minus 4ac is less than 0, then it isn't factorable. So let's see. 58 squared minus 4 times 126. Well, what's that going to be? Let's see. 58 times 58 is 3364, and then 4 times 4 times 126 is 2016. Okay, so this is further factorable. We are able to factor this further. But on the other hand, if we were to factor this further, what type of answers would we get? We might get answers that aren't applicable to the situation, but we still must try and make sure. So let's do that. There's not a lot of space here. I'm actually just going to grab another page to show that, because it does turn out, actually, I think that 3 will be the only answer, but we want to show why that is and not just kind of take it for granted. Okay, so here we have 4x squared minus 58x plus 126. And we're trying to factor this further. So to do that, we're going to use the quadratic formula, because this looks like a very challenging thing to factor without. So we're just going to use the quadratic formula. Okay, so negative b, so negative 58 plus or minus 58 squared minus, let's see, b squared minus 4ac all over 2a. That's going to be 58 plus or minus. Let's see, what number is under our square root sign? 58 times 58 is 3364, minus 4 times 4 times 126 is 2016 over 8. So 3384, or no, 3364 minus 2016, and then square root 36. Okay, so we're going to get 58 plus or minus 36.7 approximately over 8. Now, what's the trouble with this answer? Well, let's do plus first. If this is plus 58, or sorry, plus 36.7 divided by 8, that would get us 11.8. Or what's our other answer if we subtract? So 58 minus 36.7 is equal to 21.3, and then we divide that by 8, and we get 2.6625. Okay, so we actually solved in 2 ways, and keep in mind the question just said they wanted to solve. They didn't say we had to actually fully factor, but now we factored and we figured out that the answer could be x minus 3, or the answer could be 11.8 or 2.6625, that any of those ways would work and that it would be valid here. So what are we going to do therefore? Well, 11.8 isn't applicable. If we look back at this picture, unfortunately, 11.8 is just not going to work here, right? Now, why not? Because if we had 11.8 here and 11.8 here, it just doesn't make any sense, right? It's not going to work. Because the whole length is 15, so the two added together can't be 15 itself, or greater than that. And 11 point something plus 11 point something is going to be greater. Okay, now what about 2.26625? Well, that could work. And so could 3 as well. Okay, so therefore, the dimensions of the squares to be cut to create this box would be either 2.6625 centimeters or 3 centimeters, because remember, we already found that 3 was a solution before, so we're going to keep that. Awesome. So let's write a quick conclusion statement. Therefore, the dimensions for these squares are either 2.6625 centimeters by 2.6625 centimeters, or 3 centimeters by 3 centimeters. So those are our 2 possible answers. And that's interesting. I was expecting there would just be one possible answer based on the way this is worded, of determine the dimensions of the squares. It kind of implied there was only one answer, but there are actually 2 valid answers that do apply here. So that's very interesting. All right, well, very good work today, everyone. That is it for today. I know today was a bit of a long lesson, but there's another one that we're not going to do today. We will do that in the future because I know we're already over the time we're supposed to be. Next time, we'll talk about solving linear inequalities. So good work today, everyone, and we will see you then. Bye, everyone.